In this video, we're going to look at the solutions to the two practice examples we were given in our last video. Both of them involve a system of three linear equations and three variables, and we're going to do them both by Gauss-Jordan elimination. Okay, so the first example for our practice problems comes about in this way. X plus 2y plus 2z is 5, x plus 3y minus 4z is 9, 2x plus 5y minus 2z is 14. So we're going to begin by translating that into an augmented matrix. 1x plus 2y plus 2z equals 5, 1x plus 3y minus 4z equals 9, 2x plus 5y minus 2z equals 14. Okay? Then we're going to jump into the Gauss-Jordan elimination process. So we want to make sure that the number in the first row, first column, is a 1 right off the bat. It is. So we're going to be able to use that 1 to eliminate the other two numbers in column 1. So we're going to just copy row 1 over again, 1, 2, 2, 5, and then we're going to use that 1 to eliminate the positive 1. How do we do that? We take positive 1's opposite, negative 1, multiply it by row 1, which is the row containing the 1, and add the answer down to row 2. All right, so we're going to multiply the top row by negative 1. 1 times negative 1 is negative 1. 2 times negative 1 is negative 2. 2 times negative 1 is negative 2. 5 times negative 1 is negative 5. Then we're going to add the blue numbers to the middle row. Negative 1 plus 1 is 0. Negative 2 plus 3 is 1. Negative 2 plus negative 4 is negative 6. Negative 5 plus 9 is positive 4. Okay, so we've gotten our 0 here. Now we want to turn the positive 2 into a 0. How do we do that? We take positive 2's opposite, which is negative 2. We're going to multiply it by row 1, the row containing the 1, and we're going to add that down to row 3. Okay, so we're going to multiply the top row by negative 2. 1 times negative 2 is negative 2. Negative 2 times negative 2 is negative 4. 2 times negative 2 is negative 4. 5 times negative 2 is negative 10. So we're going to add those two rows together. 2 plus negative 2 is 0. 5 plus negative 4 is 1. Negative 2 plus negative 4 is negative 6. 14 plus negative 10 is 4. So we got the first column looking like we want it. Then we move to the second column. We want this number to be a 1, and it's going to be a good day. We've already gotten it there. So we're going to use that 1 to wipe out the 2 in the first row and the 1 in the third row. How do we wipe out the 2? We take 2's opposite, negative 2. We multiply it by row 2. Row 2 is where the 1 we're using is located, and add the answer back to row 1. So I'm going to take row 2 here, multiply it by negative 2. 0 times negative 2 is still 0. 1 times negative 2 is negative 2. Negative 6 times negative 2 is 12. Negative 4 times negative 2 is negative 8. So we're going to add the blue numbers to the first row. 0 plus 1 is 1. Negative 2 plus 2 is 0. 12 plus 2 is 14, and negative 8 plus 5 is negative 3. So we got the 0 in this position we want. Now we want to turn this guy into a 0. How? We take his opposite. He's 1, so his opposite is negative 1. We're going to multiply that by row 2, which is the row where the 1 we're working with is located, and add the answer down to row 3. So we're going to take the second row, multiply by negative 1. 0 times negative 1 is 0. 1 times negative 1 is negative 1. Negative 6 times negative 1 is 6. 4 times negative 1 is negative 4. Add these two rows together. 0 plus 0 is 0. 1 plus negative 1 is negative 1, is 0, excuse me. Negative 6 plus 6 is 0, and 4 plus negative 4 is 0. Well, we got a bottom row that says 0 equals 0, which is always true. And so that tells us that we have a dependent system of linear equations. Row number 2, if we read it, this is 1y minus 6z equals 4. And if we added 6z to both sides, brought it over to the right, we would find that y is equal to 6z plus 4. The first row says x, 1x, plus 14z equals negative 3. And if we bring the 14z over to the right, we'll get x is equal to negative 14z minus 3. So we write this by choosing the value for z because everything else depends on z. So we'll let z be played by our parameter t. And if z then is played by t, then x is going to be negative 14 times t minus 3, and y is going to be 6 times t plus 4. Okay? And our other system of linear equations in this video is the practice problem 2x minus y plus z equals 3, 3x minus 2y plus 4z equals 2, and 5x plus y minus 6z equals 7. So we're going to start by writing that as its augmented matrix. 2x minus 1y plus 1z equals 3, 3x minus 2y plus 4z equals 2, 5x plus 1y minus 6z equals 7. So we've got our augmented matrix. Now we want to turn the number in the top left-hand column, first row, first column, into a 1. We could accomplish that by dividing the entire row through by 2, but that would introduce fractions because negative 1 divided by 2 is negative 1/2, and 1 divided by 2 is 1/2, and 3 divided by 2 is 3/2. And so we can get around that by using the sneaky Sam approach. So what we're going to do here is to start by interchanging rows 1 and 2. So row 2 then goes up here, 3, negative 2, 4, 2. Row 1, 2, negative 1, 1, 3 goes here, okay? And the reason that I chose to do that is because I could tell that if I took 3 and subtracted 2 from it, I would get the one that we would like to have without having to introduce fractions. So I'm going to take now row 1 and subtract row 2 from it. I'm going to leave row 2 and row 3 completely alone. So here we go. 3 minus 2 is 1. Negative 2 minus negative 1 is negative 2 plus 1, which is negative 1. 4 minus 1 is 3, and 2 minus 3 is negative 1. So here's our augmented matrix. And we've got the 1 where we want it. So we're going to use that 1 to wipe out the rest of the first column. We wipe out positive 2 by taking his opposite, negative 2, and multiplying it by row 1. That's the row that's got the 1 in it we're working with. And we'll add that answer down to row 2. So here we go. Negative 2 times row 1. 1 times negative 2 is negative 2. Negative 1 times negative 2 is positive 2. 3 times negative 2 is negative 6. Negative 1 times negative 2 is positive 2. So we add the blue numbers to the middle row. Negative 2 plus 2 makes 0. Positive 2 plus negative 1 makes 1. Negative 6 plus 1 makes negative 5. And 2 plus 3 makes positive 5. So that's our new second row. How do we turn the 5 into a 0? Well, we take 5's opposite, which is negative 5. We're going to multiply that by row 1, which is the row where the 1 is located, and we're going to add the answer down to row 3. So here we go. Row 1 by negative 5. 1 times negative 5 is negative 5. Negative 1 times negative 5 is positive 5. 5 times negative 5 makes negative 15. Negative 1 times negative 1 times negative 5 makes positive 5. So we add those two rows together. 5 plus negative 5 is 0. 1 plus 5 is 6. Negative 6 minus 15 is negative 21. And 7 plus 5 makes 12. So we've got our first column, just like we wanted. And we're going to move over and deal with our second column. So our second column is we need to have a 1 located right here, and we're lucky enough for that to happen. So let's go ahead and use that 1 to eliminate the other numbers in its column. So how do we eliminate negative 1? Well, to eliminate negative 1, we take his opposite, which is positive 1. We multiply it by row 2, which is the row containing the 1 we're dealing with right now, and we add the answer back up to row 1. Well, if you multiply row 2 by 1, you still get row 2. So this is really just row 1 and row 2 added together. Add those two rows. 1 plus 0 is 1. Negative 1 plus 1 is 0. 3 plus negative 5 is negative 2. And negative 1 plus 5 is negative 4. Okay? So that's our new first row. We're going to leave our second row completely alone. And then to get our new third row, we're going to need to eliminate positive 6. How do we do that? We take positive 6's opposite, which is negative 6, and we're going to multiply that by row 2, which is the row containing the 1, and add the answer down to row 3. So we're going to multiply row 2 by negative 6. 0 times negative 6 is 0. 1 times negative 6 is negative 6. Negative 5 times negative 6 is 30. Negative 6 times 5 is negative 30. And we add those together. 0 plus 0 is 0. 6 plus negative 6 is 0. Negative 21 plus 30 is 9. And 12 minus 30 is negative 18. So we have the first column like we want it. We have the second column like we want it. We're moving to the third column. Okay? So to get the third column like we want it, we first of all have to turn this 9 into a 1. And we've got very little choice at this point, but just to divide row 3 by 9. We'll leave rows 1 and 2 completely alone, and if we divide row 3 by 9, we get 0 divided by 9, which is 0. 0 divided by 9, which is 0. 9 divided by 9, which is 1, and negative 18 divided by 9, which is negative 2. And finally, then, we're going to take that 1 and we're going to use it to eliminate the other numbers in that column. To eliminate negative 2, we take negative 2's opposite, which is positive 2. We multiply it by row 3. That's our row with the 1. And we're going to add it back up to row 1. So row 3 is going to get multiplied by 2. 2 times 0 is 0. 2 times 0 is 0. 2 times 1 is 2. 2 times negative 2 is negative 4. And when we add those together, 0 plus 1 is 0, 0 plus 0 is 0, 2 plus negative 2 is 0, and negative 4 plus 4 is 0. So that's our new first row. And our very last step is to turn this negative 5 into a 0. How do we do that? We take negative 5's opposite, positive 5, multiply it by row 3, the row that contains the 1 we're working with, add the answer back to row 2. Okay, so here we go. We're going to multiply row 3 by 5. 5 times 0 is 0. 5 times 0 is 0. 5 times 1 is 5. 5 times negative 2 is negative 10. And we're going to add those blue numbers to row 2. 0 plus 0 is 0. 1 plus 0 is 1. Negative 5 plus 5 is 0. Positive 5 minus 10 is negative 5. And we leave row 3 alone. And there is our final matrix. And we can simply read off the solution. X equals 0, y equals negative 5, and z equals negative 2.